Number 4, a mass suspended from a spring is pulled down from a distance of 2 feet from its rest position. The mass is released at time t. If it returns to its position after 1 second, find an equation that describes its motion. Then find out what 2 times within 1 cycle is the spring at 1.5 feet above its rest position. So above its rest position, you're going to have 1.5 feet, and you're looking for 2 different times. So again, I don't care if you use sine or cosine here. I just use sine, but let's make it easiest on ourselves and look at our graph first. So our max height here is 2, and it's being pulled down 2 feet. So that means my midline is at 0, my amplitude is 2. So my cycle is every 1 second, so it's just 1. So I can break these up to be intervals of 4. So 0.25, 0.5, 0.75, and 1. So let's find b. So solve for b, we get b equals 2 pi. So my vertical shift is 0. So thinking about sine, I have y equals 2 sine of, so we're going positive sine now. So 2 pi times t minus 0.25 plus 0. Okay, so we need to solve this for t. So divide both sides by 2. Plug in 1.5 for y. So again, this 2 pi I changed to be into degrees. So sine of 360, make sure that your calculator is in degrees when you do this, if you change it to degrees. So sine of 360 times t minus 0.25 equals, so where did this come from? Just 1.5 divided by 2. Cancel out your sine by taking the inverse. So I have 360 times t minus 0.25 equals sine inverse of 0.75. So this becomes 360t minus 90 equals, so sine inverse of 0.75 is 48.59. Remember, we also have to say 360 minus that, which gives me 311.41. So now we just solve both of these. Add 90 to both sides, so we get 360t equals 401.41. And also 360t, once we add that, we divide by 360, so we get t is approximately 0.38 seconds, and then t is approximately 1.12 seconds.